Okay, we are moving to the end of this chapter, 12th class, 3rd chapter current electricity, 20th session, and we want to discuss some basics of potentiometer. Potentiometer. First of all, I will explain what is potentiometer. No, what is the principle of potentiometer? Before I say anything about potentiometer, I will make you to come to the concept. Okay, just take one example. You have two cells connected with a galvanometer. Okay, one is having cell E1, internal resistance R1, E2, internal resistance R2. Now, this is a galvanometer or ammeter, whatever it be. This connection you just see, positive connected to the positive and negative connected to the negative. So they will be counteracting. They will be counteracting, like this cell will be trying to make a current in anti-clockwise direction, while this one will be trying to make a current in the clockwise direction. Okay, but both the currents will not be existing. There will only be one current. Whatever it be, there will be only one current. That is determined which one is more, which EMF is more and all. So let me explain how it happens. If E1 is greater than E2, if I say E1 is greater than E2, I will say this cell will be dominating the other cell. E1 will be dominating the other. So net EMF will be equal to E1 minus E2. And the current I will be equal to E1 minus E2 divided by effective resistance will be R1 plus R2. And that current will be like this. E1 is greater than E2. Okay, that current will be clockwise. So current will be, anti-clockwise, sorry, like E1. E1 will be dominating E2. So ultimately E1 will win the game and E1 will make the current to flow. So current will be flowing like this if E1 is greater than E2. That is the case 1. And for the next case, if E2 is greater than E1, in that case, if E2 is greater than E1, what happens in that case? If E2 is greater than E1, this will dominate the other cell. E2 will dominate E1. So in which direction the current should flow will be determined by E2 only. Now I should say the net EMF will be equal to E2 minus E1. Net EMF will be E2 minus E1. Current will be equal to E2 minus E1 divided by R1 plus R2. Okay, current will be equal to E2 minus E1 divided by R1 plus R2. That will be the current. E2 minus E1 divided by R1 plus R2. That's the current. And that current will be determined by this E2 only. So the current will be clockwise. So it will be making a current to flow clockwise. Now, what next? If the case is E2 equal to E1, current will be equal to 0. No current will be existing. See, you understand that? No current will be existing if E1 equal to E2. So this one we understood. Now let's see how we can apply it. Imagine, okay, listen it very carefully. Imagine E1 is a cell that you don't know. Just imagine E1 is a cell that you don't know, whose EMF that you don't know. You don't know what is the value of EMF, you want to find it. So this is an unknown EMF or unknown cell whose EMF you want to find. And E2 is a source of EMF. is a cell whose EMF can be varied, whose EMF can be changed from 0 onwards. Suppose 0 to 50. 0 to 50, this EMF can be varied. Suppose I'm just giving a rough example, that's all. Ready? Ready? Actually, even you don't know. Even you don't know. Even you don't know, but E2 is a source of EMF whose value can be varied from 0 to 50. And you want to measure E1. See, the situation is very simple. The situation is very simple. How? Connect like this. How? Positive connected to positive and negative connected to negative. And connect a galvanometer in between. And make a current to flow. Now imagine, E1 is an unknown value that you don't know. Make E2 0. Right? Make E2 0. So current will be determined by E1 only. E1 will be making a current to flow like this. Now you slowly increase E2. Now when you increase E2, current will be like E1 minus E2 by R1 plus R2. So the current start to decrease. Isn't it? So you slowly increase 0, 1, 2, 3, 4, 5. Current start to decrease. Current start to decrease. Suppose when the E2 is equal to 8 volt. Suppose, why? Because E2 can be varied and that can be seen in the digital meter also, suppose. Suppose you have something like that, whose value can be measured. E2 is something which can be varied and varied value can be measured. Suppose at a particular value of 8 volt, current shows 0 reading. At a particular value of 8 volt at E2, current is 0. What does it mean? What does it mean? E1 equal to 8. Isn't it? So you change the value of E2 from 0 onwards, slowly increase the E2. Slowly increasing the E2 will result in the reduction of the current because E1 is a fixed value. In E2 you are increasing, the current will start to decrease. At a particular value of E2, the current drops to 0. That means the value of E2 and E1 are equal now. So if we have a source, whose EMF can be varied, and varied value of EMF can be measured. Suppose you have a source whose EMF can be varied and the varied value of EMF can be measured. Then you can find the value of unknown EMF. That's it. I will repeat. If you can vary the value of an EMF and varied value can be measured using this connection, you can measure the value of an unknown EMF. That's all. And how can you create a source whose value can be varied and varied value can be measured? That's our next question. How we can construct a cell or how we can construct a source whose EMF value can be varied and varied value can be measured. That's our motive. For that, let me consider one situation like this. I have a wire, suppose like this. I have a wire, suppose a 10-meter wire, 1 meter, 2 meter, 3 meter, 4 meter, etc. like 10 meter. You imagine it's a 10-meter wire. Okay. Now make a current to flow through this. For this we need a cell. Just connect like this, a cell. If you need connection and disconnection, you can take a key. This is a key. Okay, that's all. Now through this wire, what happens? Through this wire, current will flow. What is the total potential difference of the wire? That will be current into resistance of wire. Isn't it? Ready? So voltage will be, potential difference will be I into resistance of the wire. You got it, right? Now, suppose you want to measure the potential difference. Suppose you have a voltmeter like this. Suppose you have a voltmeter and again you have a jockey. Suppose you are moving a jockey and your jockey is at this position now. Whatever it be. Or else you can imagine like you take any length. See the resistance, the potential difference across the across the whole length. Whole length is I into resistance of wire. That will be I into resistance of wire is rho L by A, where L stands for the total length of the wire, right? Now what will be the resistance of any length? What will be, suppose this much length is L, this much length is small l. What is the potential difference developed across that length only? That length only. The potential difference across that length only, B dash, will be equal to I into resistance of that length of wire, right? Isn't it? See, you take any length of the wire, you take any, see the entire length you take, the entire potential difference is I into total resistance of the wire, because the current start to flow from this. From the cell, the current start to flow. So the total potential difference across the length of the wire is current into the whole resistance of the wire. That is equal to rho into full length divided by area. Now I am taking a small length within it. Suppose a small length within it. What is the potential difference in that length? V dash is equal to I into resistance of that length of wire. And what is that? I into rho into L by A. Okay? So what are you getting? What are you getting? Voltage developed across any length of wire, equal to, see, current you have to make it constant. Current you have to fix what much current is flowing, rho into length of that section of wire divided by what? Area. And that area is a fixed value. That area is the fixed value. The value of area is a fixed one. So if you fix current for a particular matter, the resistivity is a constant value. And if you fix the current, make the current fixed, and area, uniform cross section, if you take a uniform cross section wire, this area can be fixed also. So the V developed across any length of wire, V developed is proportional to length of that wire. So by changing the length, right, by changing the length, you can change the potential difference, isn't it? By changing the length, you can change the potential difference. By measuring the length, you will be in a position to measure the potential difference also. By measuring the length, you will be in a position to measure the potential difference also. So you can create a source whose value can be varied, and varied value can be measured. So this requirement will be over. So you can find out the value of unknown EMF. This is what the principle of working of potentiometer. This is the principle of working of potentiometer. And we will see in the next class how it happens and how it is being used. Okay. Thank you.